Bloop. Now we're recording. All right. Yeah. Bloop. So, um, we were doing all these kind of probability kind of questions. I think this fastener ones is like literally on the homework. So let me go ahead and tell you, over the weekend I did a lot of stats homework. I went way ahead. I did a lot of good stuff. So yeah, I saw this on the homework, and I'm going to do it again with you here in just a few minutes. This right here is not on the homework, and I just didn't want to waste your time because it's not there, so I'm not doing it. Hello. This one is, I think, on the homework, or at least something very similar. So I want to do this one for you, and then we're going to do some homework and kind of just review on what we were doing. Is that cool? Because I had pushed the due date back a week. So like we're just basically like we're almost done. Okay, so it says access code for a car has 7 different digits. The first and second must be odd. No repetition allowed. What do we do? So I've always like tried to draw it out like a picture. And so we've got, that's 5, 6, 7 different digits. And again, there's no repetition. So like you can't do 1 1 1 1 1, right? You got to do a little bit differently than that. But they're saying that the first 2 have got to be odd. So I'm going to first start with that. How many odd numbers do we have in the first digits? 5. Exactly. So I got 5 different options. But again, without repetition. So if I choose 1, I can't use 1 again. How many odd numbers would be left for me to pick here? 4 of them. Okay, awesome, awesome. And now this is anything, and all the way down, these are any kind of numbers. But again, though, if you think about it, I've already chosen 2 of them, right? So I had 10, and I've already chosen 2 of them. Therefore, how many would I have left over? 8. And then, and 6, and 5, and then finally 4. What do I do with all these numbers? You multiply them. Very good. So I'm multiplying all these numbers together. And I'm just going to give you the answer because I don't need to pull up Desmos for this just yet. There you go. It says you forgot your code. What's the probability of getting it right on the first try? So you do one code selected divided by a total of these like 100,000 something total, and there's your answer for that one. That's pretty easy. Anyways, so there we go. We're done with the workbook now. I want to go through the homework and pick out the ones that are really more difficult, especially the fasteners one, and I think there's another one in particular. So, is that okay? Yay! Any questions before I move on? 5, 4, 3, 2, 1. Here we go. All right, I'm going to pull up the homework then. I don't want to waste a lot of time on these multiple choice ones. You know, it's not really a big deal. And these right here are Desmos. I'm just going to do 1 or 2 just to demonstrate how easy they are. So when it says a number and then a P and then a number, they're talking MPR. Again, there's like under the func, you can go and click it if you like. But it's always the first number and then the second number. Very quick and easy. No big deal at all. 362-880. Done. Right? If we have 2 separate numbers, then you put the first number first and the second number second. So here we got the NCR. First number first, second number second. I don't know what just happened, but I want to make that bigger. There we go. So is that, we're like coming back? That's okay. That's just calculator stuff, right? If you remember, the P is for when order is important, and the C is when order is not important. But we'll see that here in a second. Okay, let's see what else we got. Oh, these are easy. These are the multiply ones. So a man has 6 shirts and 3 ties. How many different ways can you do it? So the word and, you see the word and? And means to what? You remember? Multiply. Yep. So 6 times 3. What is 6 times 3? 18. Bam, right? So some basic math here. Just reminding, I guess. So far, so good? If there's a hard one, I definitely want to stop and really talk about it. Oh, yeah. 13 different ways to rearrange things. And so what's going on here is that I got 13 times 12 times 11 times 10 times 8, or yeah, times 9 times 8, blah, 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 blah. That just gets too much. Isn't there a quicker way to do these guys? You remember? 13, what? 13? 13, right? The factorial? Yeah. Now, how am I going to put this thing in here? I can't really remember. Times 10 to the power of 9? Is that going to, no? Is it 13? How many ways to get in 13 songs? Yeah. I'm pretty sure this is how it works. You know what? How was the thing? This looks kind of crazy. I don't really know how to do it, so I'm just going to get it wrong 3 times. Just want to see. Oh, yeah. Did I get the same number? Look, did I get the same number? Just that I have to, like, expand it, right? So I have to, like, actually get it the full length. So let me try that one again. Oh, that's way better. Oh, my gosh. 6 factorial. Look. So if you get one that's so big that you can't even handle it, just go ahead and just, you know what I mean? Cycle through. You'll find something that works a lot better. Is that cool? Okay. Part of the homework, right? Just kind of get the easier questions, honestly. So that's not too bad. Okay, so these are multiple choice. I'll let y'all do the multiple choice. I'm not worried about those guys. Okay. Codes. We just did something like this, actually. So we have a 9-key keypad, 1 through 9, and we need a 5-digit code. How many different codes? It says the numbers can be repeated. Didn't we just do this a second ago? Here, let me pull this over here. Get a little bit of room over here. Okay, so I've got 5 keys, and I can go 1 through 9, so I can't use 0. How many options do I have for this guy? How many different digits? 1 through 9. What do I get? 9. Very good. But it says I can repeat it. I can repeat. So how many options? 1 through 9. How many options? 9. How many options? All the way down. So multiply, multiply, multiply. Or, you were saying earlier, 9 to the what? Yeah, 9 to the 5th power. Yep, just like that. 9 to the 5th power. Cool. This is just review. I want to make sure that y'all are okay. If I'm looking for the hard ones, of course. It says, what's the probability of like choosing one? So then you just put a 1 at the top. That's easy. Are y'all okay with the probability part? You just put a 1 on the top, right? We just saw that a second ago. Okay, let's keep cruising. Okay. Here's the cool stuff. Okay, clear it out. Here we go. So again, if you remember, the NPR is when order is important, and NCR is when order is not important. Okay, so those are the two differences. So you help me, like as a human here. We got a car race. Is order important? Is order important when you're racing cars? Yeah, because you want to be first, right? NPR. And I have a bigger number and a smaller number. What's my bigger number? 43. Yeah, what's my small number? 3. There's my answer. We're done. So it really comes down to just that question, is order important or not? And from there, we just put in the 2 numbers and we're done. Very, very quick and easy. Like, this is your homework. This is not too bad, right? Okay, cool. Hi. You had squeaky shoes for a second. Well, it's good to see you. So we got people on a committee. There's a chairperson, vice chair, secretary, treasurer. Is order important? Is there a ranking? Yes, exactly. So NPR. What's my big number? Sweet. How many am I selecting, though? What's my smaller number? Yep, each person. So chair, vice chair, secretary, treasurer. How many is that? 4 people. You just jumped right in, man. Yeah. Yeah. Yes. Oh yeah, definitely. You got it. Is that okay? Let's see what else we got ahead. Yeah, more lottery stuff. Again, order not important. I want to find some harder ones. That looks like a lot, Chad. Look at that one. Doesn't that look like a lot? So a certain three-cylinder combination lock has 70 numbers. To open it, you need to turn a number on the first cylinder, and then a second number on the second cylinder, and then a third number on the third cylinder, all the way down. Okay? Repetitions are allowed. Any of the 70 numbers can be used. What are they talking about? So is order important? In PR, I got 70 numbers, and how many am I selecting? 3. Yeah, it says 3 cylinders, so 3. I don't know if this will work, but we're going to try it. And it says, and the reason why is very subtle. It's very subtle. You see right here, it says repetitions are allowed. So how many options do I have the first time? 70. How many options do I have the second time? And then again, 70. Exactly. So I think this one's actually a little easier. See? And then what's the probability? Literally, you're just doing 1 over that same number. Yeah, I don't worry about the second part like ever. It's always 1 over. Is that cool? Okay, cool. Awesome. Keep cruising. Lottery stuff. Again, I think we talked about it. I'm not worried about it. Jury selecting. This is it. This is it right here. This is the one. Okay, so jury selecting and the fasteners. These are the two that are a little bit weird. I want to talk about them for sure, okay? Let me erase some of this and get like a little bit of room. So what I'm going to have to do is what I call the box method, but really I'm just like grouping them. Here we go. So I'm grouping them into 3 different groups. And let me read this problem a little bit more detailed. It says, blah, 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 blah. There's a jury, and we have students and we have faculty. So we have right here, we have students, we have the faculty. So far, so good? Okay. And the bottom, I'm going to call that the total. And then I guess you can say there's multiply in here. So we're picking someone for a jury. Is the order in which you're picked important? If you're the first juror selected, is that any different than the second juror selected or the third? No, they're all, it doesn't matter. Order's not important. So if order's not important, I'm going to put a C because order's not important. And then we need to fill in the numbers. So how many students do I have? 8 students, right there, 8 students. How many faculty do I have? Perfect. Now remember that these two numbers, they'll add up to be right here in the total box. So what, 19? Total? Right? I should have used a different color. You think I can go back and do that again? Yay! I'm making it work. Sure. Ah, so much better. Aren't you so happy? Okay, and then we're selecting. It says, what's the probability of all students? Okay, so how many do we need on this jury? We have 8 students. Is it 6? Yeah, 6 right there. See it? So it says probability of all students. So how many students? We have 8 students, but selecting, I'm going to do selecting 6 of them. How many faculty am I selecting, though? 0. And whenever I'm adding these up, I should get a 6 again, right? So what's going on here is that I have, I'm going to just, I guess I could do that. I'm going to do 2 sections here. NCR, that ain't it. NCR, we got 8.6. NCR 11.0. And I got NCR 19.6. There's my answer. 0010319917744. Just in case. Yeah, what's up? So NCR, oh, right here, I already wrote it at the top. NPR is order is important. The NCR is when order is not important. That's the only thing. It's more like a human thing. We have to think of it like a human. What would a human say? Is order important or not important? Hello. Okay, cool. Let me try this out. It says 5 decimal places. So 0, 0, 1, 0, 3. Can't even type that. Yay! Awesome. So what's the probability of all faculty? Let me use a different color here. We'll use brown, I guess. Okay, so all faculty. So how many faculty am I selecting then? If it's all faculty, how many? 6. 6 faculty. How many students though? 0 there. And then of course you get the 6. So I'm changing it up just a slight bit. Here we go. So I'm going to change it now. This would be a 0. Over here, this will be a 6. And there's my new numbers. 0, 1, 7, 2. Oh, whoa. I'm all wrong. 0, 2, 7. There you go. Okay, let's try it out. 0, 1, 7, 0, 3. Cool. Okay, we got this. So and now a new one. It says, what's the probability of 3 students, 3 faculty? So how many students am I selecting? 3. How many faculty? 3. Total of 6 once again. So it's like everything's the same except I'm just changing these little numbers here. Is that making sense? Of course I'm recording this, so oops. 3, 4, 0, 5, 5, 7. Bless you. 3, 4, 0, 5, 6. Sweet. We did it. Are y'all okay with this problem? Because this is the biggest problem that we're having today. Yeah. Maybe. I haven't seen it when I was doing the homework. I don't think I've seen it. So probably not in this class. But like in reality, yeah, definitely. There's definitely an option there. No, does not matter. Does not matter, yeah. And CRs does not matter. See this defective stuff right here? This is literally the same problem. Can I do it with you guys? Is that okay? Because it's the same kind of problem. I just want to make sure we're cool with this, okay? So we're talking defective, not defective. So I'm going to fill up my little boxes, okay? So I got defective, not defective, and then total. Now, it says to determine if it's acceptable, they're going to select this and that. Is order important in which you're selecting these components? Is the order important? I'm just going to say no. I'm going to tell you it's no. It's okay. Doesn't really matter. So how many defective units do we have in this crate? 3. How many not defective units do we have? Yes, 140 minus the 3, 137. And so because my total is 140, right? Awesome. How many am I selecting? It says if 1 or more are defective, then it's rejected. So right here, 1 or more. So in a way, I'm wanting to select 1, 2, 3, or even 4. I guess not 4 because we only got 3 total. How about we do something a little different? What if I find 0? What if I find 0 defective? It's the opposite is what I'm doing here. You see how it says right here, 1 or more? What's the opposite of 1 or more? 0, none, right? Yeah, exactly. So I'm going to say, let's do none, and I'm going to like do the opposite number, basically. Okay, that's what I'm thinking. Instead of having to add up all these other numbers, I'll just do 0. And therefore, when I'm selecting, it says, how many am I actually selecting? It says right here, 3. 3 of them. So how many total am I selecting are in my hands? Again, 0 and 3 makes 3, yep. You can see that it makes that whole total thing on when you're adding them up. So here we go. Again, in CR, 3, 0, and CR, 137, 3, 140, 3. Here we go. So this is the number where it's not defective. We found no defective units. Everything's fine, right? So let me go back. It says, what's the probability of being rejected? Isn't that the opposite? So I'm going to say 1 minus that amount to get the opposite effect. So 0, 6, 3. That's another 6 right there. So another 3, 6, and then 3. Chad, how did you do that? I probably did it wrong, so hold on. Hey, it worked! Do y'all know? Can I show you a small trick about how to always subtract from 1? It's actually really cool. It's like a small little math trick. So what if I had 1, 2, 3, and I wanted like 1 minus it? So I always add these numbers up here to be a 9 and a 9, and the last one's a 10. So what makes a 9? From 1, it would be an 8. 1 and 8 make a 9. And then 2 and 7 make a 9. But this one, to make a 10, I need a 7. Because that's the one that like rounds up. If you had a 10 right here, then it would carry all the way down. Yeah. So that, 1 minus. Everything else is a 9, yeah. Isn't it kind of interesting? So 9, 9, 9, and then the last one's a 10. Which, again, that 10 would carry through, making it a 10 everywhere, essentially. Yep. Thank you. Say that again? Yeah, it's just different. Yeah. Cool. Okay, let's see what else we got. Consonant vowels, assuming passwords or not. Oh, this is the last question. I want to do it just because it's the last question. Otherwise, I would have just skipped it. So it says that we're going to have passwords, consonant, consonant, vowel, consonant, number, number. What? Who comes up with this stuff? It says repeats are allowed. Okay, we can do this. Okay, let me get a little bit more room right here. Okay, so we got a consonant, a vowel. Oh, no, I'm already wrong. Consonant, consonant, vowel, number, number. How many consonants do we have? Okay, how many vowels? Let's start with that. 5. We got 5 vowels. A, E, I, O, U. Yeah. And it says repeats are allowed, so I'm going to put another 5 there. So consonants, how many will we have? 21, yeah, because we have 26 total, so 21 for my consonants. And then how many digits do we have? How many numbers? 10, because of the 0. Yep, exactly. So I'm going to multiply all these together. Yeah, what's up? No. Okay, consonant, consonant, vowel. You're right. Oh my gosh. How do I have to erase everything on that side. Isn't that crazy that they just don't stop? Okay, here we go. So another consonant right there, yeah? And then finally a number and another number. 10 and 10. Oh my gosh. Thank you for that. Yeah, I definitely mess up a lot. Do you think I got this one the first time when I was doing it on the homework? No. No, Chad. No. No, Chad. So here we go. 486-202-500. We did it. Whew. It says, okay, so what is that possibility? Now, I would normally say, well, it's a multiple choice. You'll be fine. But notice that it's like, I don't know about that. So let me show you what I did. Can I show you what I did? I first off said, wow, I'm dyslexic. Because they all look the same. It's not 420 because that's way more than 420, right? So it's one of the other ones. So what I did is I just went to Desmos. And I just went and put them all in and said, do I get the same number? Did I get the same number? No. Let's keep going. 420 to the power of 4. Did I get the same number? No. I don't know. No. Am I missing something here? How many passwords are passable? Oh, if they're case sensitive. Is that new? Oh no. Oh no, it is a whole new problem. So then not 26. So yeah, 42, 42, 10, 42, 10, 42, and then 10 and 10 because those are the last ones there. So that's the number that I need now. Is it 52? 26, 50? Oh, no, I'm just literally doubling it because I said these are my uppercases and I'm lowercasing it. You're right though, 52 subtracting, yes. So, yeah, So I now need to get that one. So this guy to the fourth power, did I get the same number? Okay, let's try the other one. 420 to the fourth power. Ah, there we go. So that's how I cheated my way. I meant that's how I did my problem. Yeah, that one's kind of crazy. But anyways, so we're done. We did the homework, and you saw the two harder questions for sure. I want to go back to the workbook and keep going. Then, any questions before we're done? Okay. Yeah, yeah. We got done last time. I just wanted to review. Yeah. Well, now you are. Okay, so here we go. On to the workbook again, and now we're in chapter 6. So let's start talking about what chapter 6 and onward is going to be like. They call them probability distributions. Basically, they're just like setups, like tables. And let me just fill in the blanks for right now. A lot of this is copy paste of what you've already seen. So here, this is discrete. This is continuous. We had already talked about discrete and continuous a long time ago. Let me remind you, this one is whole numbers. Whole numbers. While this is like all decimals. All decimals. So there you go. There's your simple Chad definitions. Whole numbers, all decimals. Is that okay? Okay, awesome. Okay, cool. It says decide if there's discrete or continuous. So the number of A's in this class, is this a whole number or is that going to be a decimal? Whole number. And therefore we're going to call it discrete. Yep. Okay. The speed of a car, how fast you're going, is that a whole number all the time? No. It's like you can get like 0.1 or even further than that. You're not going 60 miles an hour. You're going 60.287936 whatever miles an hour. So I'm going to call this decimals, and therefore it's continuous. Okay. The number of times basketball. Okay, the time that it takes a basketball player to throw a free throw line, I guess. Time, is that always a whole number? No way. So again, continuous. The number of cars that goes through a drive-through. Yeah, discrete for sure. Unless you got like, does a motorcycle count as half a car? If you're like, no, bro, it doesn't. I ride. Yeah, no offense to the motorcycle drivers. So anyways, they're full on cars, exactly. So good enough. These are important for the homework. I have little notes here. This is actually number 1 on your homework. It'll ask for these symbols, and you just click them. Very simple, okay? Like, don't even worry about it. But we've already seen probabilities from 0 to 100%. You add them all up to make 100. Here we go. All right, so we're supposed to add these up, and somehow this should equal 100% essentially. So what do I already have? Surely we've done this before. Have we done this before? Yeah, I thought. Okay, so let's see what we do have. Oh, 0.25. So right now what I have is 82. From all these, I got 82. And I need to get to 100%. So what would I do between these two numbers? What do I do with them? Subtract them, exactly. 100% minus 82%. 18. So 18 would be the one that we're missing. Hello. I'm sorry. Oh no. Well, I mean, you don't have to stick around if you don't want to. I understand. You know I'm recording everything. No, you just attended. You're good. No, seriously, right now you're good. I don't even care about attendance. Oh, I didn't say that out loud. Yeah, do what you got to do. Do what you got to do. But yes, please. I mean, I. Oh, there you go. That's good. It's good. We'll yeah. Yeah. We'll figure that out. Yeah, you're good. You're good. Okay, so it says, hey, is this a probability distribution right here? Basically, do they all add up to 100%? And really, the only way to do that is to just do it in the calculator. So I'm just going to add them all up and see what we get. 26, 21. See, yep, there you go. So you're good. So I don't know what you would say. Yes. I don't know. It's pretty straightforward there. Is that cool? Easy enough, right? We're just saying, does it add up to 100%? So we're going to finally make our own from this one. And I think that these are easy problems. This one's a little bit more. But are y'all okay with these? Okay, let's keep cruising. So we're supposed to set this thing up, and this took me a while to set up. And I'm going to go through it pretty detailed. Like, yes, there's the StatCrunch, and that'll definitely do the histogram part. You could probably make it do other things, but I want to go through it by hand a little bit so we can see what's going on. Okay. So first off, the X's are just the things over here: 0, 1, 2, 3, 4, 5, and then 6. All good. And then this probability, another way to call it is relative frequency, and that's going to help you when you go to StatCrunch. You can find when it says relative frequency, and then you'll probably just get the answer. Is that cool? But we're going to do this by hand, just a little bit, okay? So I need to find out what my total is. Like adding all these bottom ones up, adding up all my employees. Let's see what we get. 354, 44, 35, 18. We got, okay, 209 total. So far, so good? So then to find relative frequency, or again, probability, I'm going to do selected over total. 6 divided by 209. What's going to be the next fraction that I have? The 19 over 209. Yep, exactly. Yeah. No, you're good. No, I'm getting you. No, I completely understand. Oh, I understand. 33 over 209 and all the way down here. Obviously on the homework, they're going to want some decimals. So I'm just going to start typing that in the calculator here in a second. But just, I wanted to show you what I'm doing here. Okay, cool. Okay. So far, is that okay, guys? Are y'all understanding, like selected over total, right? Pretty easy stuff here. I'm not worried about it. Can you do this in StatCrunch? Probably. But for right now, I just want to make sure that we got the concept just in case. When I went through the homework this weekend, this homework here, I found that there was like a lot of parts, but like the questions themselves were not very difficult. I do have to say, and I'm going to be recorded saying this, I was a little bit frustrated. Okay. No. It is easy. I never found the problems hard. I found that there were so many parts, and it just kept coming, and yeah, all the time. And I really wanted to go and do something else, like anything else. But I stuck through it, and I got through the entire chapter 6 stuff. But it was a very long time doing the homework. So again, though, I never found it hard. So if y'all have a lot of patience, that's great. It was just, I don't know. I didn't make the homework up. I didn't do this. It's not me. I think the questions they ask are cool. It's just like, the parts. Okay. Is that okay so far with that? What we need to do now is actually make the histogram. How we do this, it's kind of, I don't know, it's a flexible, because again, it'll just be a multiple choice for you guys. I'm seeing that the top is about 25, so I'm going to go to 30. So what I'm going to do here is make 3 tick marks. This one will be at 10%, 20%, and 30%. I'm just kind of making something up. And then I start making my bars. So the first one goes to 2%. That's very tiny, like right here. And to be like super professional, you can put how much and even the number below it. It was like the 0 bar. The next one's 8%, so it goes up a little higher. That's a 1, and again, it went up to about 8%. The next one's 15%, so about halfway between those two guys. A 2. Are y'all seeing what I'm doing? If this was a multiple choice on the homework, do you think you can get it? I thought so. On the homework, it's all multiple choice, yeah. You don't have to do any of this. Which is actually, I have a small story while I'm doing this. We had the stats class using a different program, not my math lab, but it was something else. And in that program, you had to draw all these by hand in the program itself. Yes, it is. Yeah, well, you said it, and it's not being recorded. It was glitchy and buggy, to say the least, and it was very difficult to get through some of these problems. It was sad. So my math lab is significantly better, even if it's annoying, even though there's like 11 parts sometimes. At least it works. At least it works. Okay, so that's a good thing. And there you go. Cool. Now, can you do it in StatCrunch? Probably. And I'll show you that when we get to the homework. But for right now, not too bad, right? Cool? Any questions? Okay. I'm gonna keep cruising then, okay? Here we go. Keep cruising. Go ahead. A histogram. Oh yeah, symmetric. Yes, I would say definitely. I was thinking about that. We're gonna find out when we see it. Yeah, I would personally say it's symmetric, but you're right. Who knows, right? Who knows? So keep cruising, and I got little notes in my workbook here. I'm gonna show them as I go. I am not concerned at all with any of this. I don't think I used any of those ever. I went right to StatCrunch for all this, but man, I got a ton of notes on this one. Okay, so like some of this is very important. I'm going to show you how to use it. Very simple, but also a little bit interesting. So they want to know what the mean, variance, standard deviations. Can I find the mean by doing this stuff? Like I would multiply and add it up. That'd be fine. It wouldn't take that much time. But these other two, no way. No way, no way. So I'm just going to pull up a StatCrunch and start showing you what I did for this problem, okay? And it's going to be a little different. So first off, I need to like fill in my notes. So I got a 1, a 2, an 8, a 9. You see that? It's not 1, 2, 3, 4. I know, that's kind of... And then I wanted to say 1/5, 1/5, 1/5, 2/5. But it doesn't compute that, honestly. It just doesn't understand. Like I got the wrong answer. I'm just telling you. I went and did it. I got the wrong answer. So it just that doesn't work. Right, exactly. It doesn't understand a slash. Very good. So let me go to Desmos again, and I'm just going to find out what are these fractions, right? I just want to know what the decimal is. So 1/5 is 0.2. Okay, so that's cool. So 0.2, 0.2, 0.2, and then this will be a 0.4. Okay, so I like that. That's great. No problem. When I start doing stats, summary stats, group bin data, because again, we got 2 different groups. I'm going to choose 1 and 3. I want all this stuff. But here's the problem. I hit it, and it's going to say no good. So I need to make them into integers. I need to go back and change this here to numbers, like whole numbers. So can you imagine? 2, 2, 2, and exactly. So don't make it complicated, right? But let me tell you, how many times did I do that on the homework, right? So we're going to see that again when I pull up the homework later. So now I'm going to use 1 and 4. when I start doing this. Go away. Okay, so here we go. Stats, summary stats. Group bin data, again, is because I got 2 separate columns. 1 and 4. Again, I want to select everything, and it should now work. So it says find the mean. Easy. Got it. 5.8. I'm telling you, if you didn't do any of that and you left a slash, it would be the wrong answer. I tried it. It does not work out. Variance. So you would think there's variance right there, and that looks totally great. That would be incorrect. No, they want the unadjusted. Yep, I know. And I'm going to explain more why, like in just a second. But right now, what they want is the unadjusted. I'll tell you more specifically in just a second. Unadjusted. And this is also unadjusted. So 3.544. Oh, I'm wrong. It was the 12. This was the 12.56. And this is the 3 point. Yeah, I know. I flipped it there. Okay, cool. So let me tell you what's going on. There's 2 things that we need to take away from this, okay? If the second column is probabilities, I need more room to write this thing. If the second column is probabilities, then you're going to use the unadjusted, okay? Unadjusted standard deviation. I don't think they ever ask for variance. If the second column is just numbers, just regular numbers, then you just need to use the not unadjusted. I don't know, what would you call that? The original, the ones that were like way over here. The regular standard deviation, the regular one, yeah. So that's how we're going to have to know the difference. Again, is either you have a regular number, it's just a number, and you get regular standard deviation. But if you have a probability, then you have to have the unadjusted. That is the big thing going into this homework. And they're going to do both. They're going to do both. They're going to have whole numbers, and you're going to lay like, I need a regular one. But if they have a probability, it's all over. You have to use unadjusted. Okay? So that's my little warning sign. And I did the homework this time. I did the homework. So I tell you, this is it. Okay, last bit. This is actually very simple. But they repeat the same question again and again and again. It says, interpret what this means. If it keeps increasing, it's going to approach the mean, and I think that's it. That's all you're going to be looking for. Okay, that answer you'll just copy paste it about 15 times. It's really not a hard thing. Just look for that number. That answer. As the number of things increases, you're going to approach the mean. Because there's other words, but like this is your answer for every one of them. Oh, because they're going to ask this part here, this question, like for every single question on the homework. And so like it's the same answer every time though. So just click that top one, you're good. Yep. Cool. Okay. So when I was doing the workbook, I spent a lot of here, hold on. This is called the mean, and I'm going to explain a little bit more on this first. Give me a second. I'll go back to my little story here in a second. Average. Okay, so if you ever see the word expected value, they say it's just the same as saying mean or average, okay? So expected value is the same as saying mean or average. That's it. If I said then, hey, what's the expected value of doing a lottery? You're saying what's the average money you'll make? What's the expected value of the height in the room? I'm looking for the average. That's all. Cool so far? Okay, so that's expected value. This problem right here is not on your homework. And I'm not kidding you, I probably spent about 15 minutes trying to get this thing to work in this tiny little box. Do you see how tiny this box is? Do you think I could fit everything in there? No way. So it's not on the homework. I'm just letting it go. I literally have a blank there, except for all the eraser marks. Keep moving. This one's on there, though, for sure. So we have a roulette wheel, and that means 38 different numbers, and you can bet $1, and then you would keep your dollar, and you get an additional 35. But if you lose, they take your dollar away. What's the expected value? Whoa, whoa, whoa. What do they mean by expected value? What does that mean? Mean, average, exactly. What's the average dollars that you're going to make or lose in this game? And so here's my setup. I'm going to show you what I did. I said, okay, I got my X and I got my probability, and I need to do two different situations. I could win or I could lose. And I want to see how much dollars I get. So this X, this is essentially dollars. If I win, how many dollars have I gained in my pocket? How many dollars did I gain if I win? 35. I gained $35. But if I lose, how many dollars would be in my pocket? 0. But like if we're going negatives, because I'm losing it, right? -1, exactly. I'm losing my dollar. Perfect. So yeah, I'm losing $1. What's the probability of winning? Well, they have 38 numbers, and I'm picking one of them, right? So 1 out of 38. So the probability of losing would be then, yeah, we're going to get -$1. The probability, though, would be, yeah, 37 over 38. Yep. It's the opposite of it, right? Yeah, it's the opposite. Yep. What I did is I just simply multiplied these across, and then I added it up and got a number. So, like, I'm going to show you in the calculator, but I did 35 times 1 over 38, and then I said minus $1 times 37 over 38. And that's what I did in my calculator. So let me pull that up. So let's see what's the average amount of dollars that I would win or lose at this game of roulette. And I got a -5 cents. Like, this is still dollars. So basically I'm losing a nickel on average every time. So I can play and I can play and I can play. And if I play, look, if I play 1,000 times, I'm going to lose over time, right? I'm losing a nickel each time, essentially. Now I might gain a little, and I might lose a little, but in the end, it's like I'm losing a nickel each time. And so, a nickel? Oh. Well, I guess I'm old school. So I'm going to take that number, and you can go out however many decimals, it doesn't matter. But we're looking for how many dollars would I lose. So I did 1,000 times my nickel. And so, yeah, I lost $52 essentially. I don't know what they're wanting, but there you go. Just times it by 1,000, right? Yep. Very good. On average. Again, that's the average. Cool so far? Okay. I have to prep myself for this next one. I went through the homework, and this one here, I'm going to be honest, I yelled at it. I yelled at this problem. I was so angry. I'm not kidding you, I was off by a couple cents, and I was so upset. We're talking about $25,000 here, and I was off by a couple cents, and it was like, no, you can't have it. It's totally wrong. Whew, man, I lost it, bro. So let me show you how to do this problem. I had to erase this one so many times, okay? The idea is that we're buying life insurance or something. It costs $350 to do it, but we get that much back if we die, I guess. I don't know, something like that. So, but then there's a high probability that you'll be living. So how does this work? Let me show you. I'm going to do 350 times that 998,937. Let me try to write that a little bit more clearly. 998,937. Okay, so I did that one. And then I had to subtract from it, okay? Subtract from it the $250,000. Okay, you see all that right there. I'm subtracting the 350 from it because here's the thing. I lost $350. If I die, I get this much, but I'm still out $350. Now hold on for a second, guys. For one, is this life insurance? Would you care if you lost $350 if you died? Okay, so that's part one. Makes no sense. Part two, your spouse has $250,000. Do they care that you spent $350? Let me just tell you, it's probably yes. Okay, so this one's made for you. So yeah, you're out $350 still, okay? But now I need to multiply it by the probability. The probability is 1 minus this 998937. It's basically the opposite of this guy, okay? So again, this thing here minus this thing is equal to your answer. On your homework, this is what you do. When you see this problem, you literally just replicate what I'm doing here. Are you feeling me here? Yes? I mean, I know it's kind of like, wow, that's a lot of craziness going on. You better believe it, okay? You better believe there's a lot going on. But now you have the formula to get it done. And if this is on a test, boy, let me tell you, I'm going to be looking really nice on it, okay? Because this is a crazy, crazy problem here. Trying to remember all what we're doing. So there's your formula. You have all your numbers. You literally copy paste for what you have on your homework problem. And I came up with this guy, which is totally fine. That's a great number. Again, I was literally off by like a penny or two, and they said I was wrong. I was so upset. And so it says the company gains that much or something. There you go. We got it. There it is, and that's on the homework. How can I stress that enough? Are we okay with this? Can you copy my style? Okay, good. Okay, and again, it's only one problem. Then you'll never see it again. Okay. Well, your homework's like a lot, but that one problem shows up one time. Yep, and then you'll never see it again. So now you know the strategy for that problem. Okay, I'm gonna keep cruising. Okay, here we go. Much better now. Okay, we're packing a good times now. Good times. We're gonna use the calculator a little bit here. It says go ahead and list out what the probabilities are for all these. Very simple to do this. I'm gonna find what my total is first. 297, 285, 700. So again, what do I do with each of these numbers? So I got 290 over 700, selected over total, right? 285 over 700, 94 over 700. This is computers in your house. Does anybody have more than three computers in the house? I might top y'all. Technically, yeah, but let's say like actual sit down computers. I recently had about 10 computers donated to me. They're old. I do weird things with them. So but that's okay. So yeah, I probably top all of y'all for sure. And then again, I make computers too, like with chips and stuff. But that's a whole other thing. I understand. That is no problem at all. I hope you feel better. And you're looking nice. You look nice every day. See you later. Thank you. So you can see here we got 42, 40, 13, and then 3. So like you see how it's big, big, small, small, right? So which one? Right? Big, big, smaller, small. Right? A, big, big, smaller, small. Right? Again, just multiple choice. We don't have to think too much about it. And looking at this guy, would he be skewed left or right? Definitely not symmetric. Yeah, skewed right. We got that tail on the right side here, skewed right. You got it. See, that one's a lot easier, yeah? I have one last problem, and then I have some notes for your homework, and I think we'll maybe get to the homework, maybe we'll see. But the next problem's kind of easy, too. So dogs and households. Who in here has got a dog? Doggies? Oh, wow, a lot of y'all. Who in here's got 2 dogs? 3 dogs? 4 dogs? 5 dogs? Oh, for reals? 6 dogs? Oh, wow. Okay. I don't know. So, obviously, the probability goes down and down the more we have there. But it says find the probability of fewer than 2 dogs. So, what is fewer than 2? Yeah, 1 or 0. We're going to take these two numbers, we're going to add them up, and we're done with this problem. Well, okay, we're done with that part. -1 dog. How does that work? Yeah. Well, then I got -2 dogs because I got 2 kitties. Yeah. What's the probability of at least 1 dog? What would be at least 1 dog? What numbers qualify for at least 1? 1, right? What else? 2, 3, 4, 5, all those guys. Adding them all up. And I know that we can do like the whole 1 minus business, but I'm a pretty crude guy, and I just want to like see it physically play out. So I'm just adding them all up. Is that okay? Okay, pretty easy there. It says, what's the probability of 1 between 1 and 3 inclusive? So we're including 1 and 3. 1, 2, and 3. Add them up. You can see that this is a pretty simple problem. Is this okay for y'all? We cool with this? Okay. It says, are any of these probabilities considered unusual? Remember, unusual is less than 5%. So are any of these here less than 5%? The 3, the 4, and the 5, right? Yeah, exactly. So now combined, I think they might, well, they would still probably be under 5. But yeah, those I would say just, I don't know, click them, circle them, click a multiple choice, something like that. So yeah, just less than 5%. All right, so you have some room at the bottom. I must give you some more stuff here. It's not new problems. It's just things that like are going to come up on the homework. So here we go. Like if I wrote down notes for them, you know something's going on. Number 15 on the homework. You need to use StatCrunch for sure. StatCrunch. And then you're going to go to data and sort in order to find the numbers that you need. Again, I want to show you that one in particular because I found it was very difficult. Number 16 on the homework. So you need to graph and then go to histogram. And inside of that menu, they have a little like selector for relative frequency. And you need to select that. Also, on this problem, there's a formula. It's something like mean plus 2 times the standard deviation. And then I say to use a table. Use the table. Now, I don't remember what that means, but when you get there, I'm hoping that it means something. Do you ever think of like, I mean, this is probably from movies and stuff, but you got like this like treasure map something, and at the end of it, it says, press the second button on the right, and you're just like, I don't even know what this means. But when you get there, you're looking at the buttons, you're like, oh, now I know. Does that make sense? I have no idea what I wrote this for because after this, I did not want to do any more math, but it was okay. I wrote it down on purpose. There must be a reason for it, okay? So far, so good? I'm going to jump to the homework. We got a couple minutes, not very long. I just want to jump to the homework and just look around a little bit, okay? See if we can do some of these problems. So, preview. See you later. Thank you. Okay. Did you see this? Look at that. That's the very first one on our workbook. If you go back, I had labeled it. I said, hey, guys, we need this for question number 1. Right there. So I'm going to let y'all do that one. I'm not worried about it, okay? Let me get rid of this thing. Okay. So I'm not going to worry about it. Next question. Continuous discrete. Again, I'm not worried about it. Same thing. Are these all like adding up to 100 and are each one of them fine? Just multiple choice. Not worried about it. Oh, find the missing number. Is that what we're looking for? Because the sum of the problem. Oh, no. Y'all got that one. Y'all got that one. If there's ever a problem that looks like this and you have no idea what to do, guess what? You just click something, okay? Check it, and now you can see what the answers look like, and you can just get it the next time, okay? I don't worry about that stuff too much. See you later, because that one doesn't change. That's a multiple choice kind of question. Okay, hold up. This is something new. It says find the average. StatCrunch for sure. So let's go and find the mean. Let's go find the average. This is easy stuff, right? We've done average before. Oh my goodness. Give me some room. Okay, that's going to be good enough. Okay. So I got 2 different groups. Stat, summary stats, group bin data. First with the first, second with the second. Bless you. I'm going to select it all just in case. Bless you. Compute, and it says, what's the mean? I'm going to put it in, 34.86. There we go. And that was the only part to that. Are we okay with StatCrunch? Right, that wasn't too hard. Let's keep cruising. Let's see what else we got. Is this part 1 and 2 kind of thing? Yep. I'm not worried about it. Bless you. That's the same kind of thing, though. Not worried about it. Probabilities. Let me tell you, this is it. This is it right here. It says find the average, and it'll say find the standard deviation. Here we go. All right, so stat, summary stats, group bin data, right? This is very typical. I go and do the first with the first and the second with the second, and guess what? So I need to convert these over into integers. How many decimal places am I using this time? Decimals? Decimal places? For each one of these, how many decimals are we using? Is it hard to see from that angle? I'm sorry. Yeah, like the 267 and the 577 and all that. 3 decimals? I'm confused if you're confused, right? 0.267, so there's 3 decimals there? Yes. All right, cool. 3 decimals, 3 whole numbers. So 267. See you later. 577, 124, 028. Yeah, 028. That's okay. 003, 001. I'm literally just typing 3 digits, 3 decimals. Stat, summary stats, group bin data, again, X, and now I get to use that var3. So make sure to select everybody and compute. So my mean, very simple here, 926, easy enough, very cool. Oh man, I wanted it to have the standard deviation part. Okay, so I know we're going to be leaving like right now, basically. If I had to pick the standard deviation for this, like and it will ask, what's the standard deviation? Remember how these are probabilities? So which one do I use? Unadjusted, very good. That one way over here is what they're actually going to look for because it's probabilities, okay? If they had just whole numbers already, good to go, use the regular one. Cool? Okay, we'll finish this up next time. What question are we on? Number what? 6, 7, 9? So I'll start on number 10 next time. Y'all are going to remind me. Thank you, guys. See y'all later.